This is your lesson for Chapter 3, Section 5. We are solving systems of linear equations. So your packet here first sets up with some vocabulary. We have systems of linear equation, or a system of linear equation, which is a set of linear equations in the same two variables. We've got transformations that produce equivalent systems. This is basically the process of what we're going to do. These are the things we can do in order to get a system with the same solution set. So when it says same solution set, it means that it has the same solutions. The same ordered pair will make both equations true. Okay, so the first thing we can do is replace an equation by an equivalent equation. The second thing we can do is substitute for one variable in any equation that variable as an equivalent expression. Okay, and then the third thing we do is replace any equation by the sum of the equation and another equation in the system. Basically, we can add two equations together and replace one. So we're going to look at two examples. The two examples we're going to look at are here. It says solve these systems. It's got A and B. We're first going to look at A, and we're going to do this first one using what we call elimination. Okay, so that's what we've got here. We're going to do this using elimination. In this case, they ask us to eliminate y. So, the steps they give us to do are to eliminate y. We need to get y to be opposites. Okay, so if I look at 3x plus 4y equals 1, okay, and then I've got negative 3y. Okay, so I want those to be opposites, and so what I can do is I can multiply the first equation by 3 and the second equation by 4, and when I do that, I will get 12y on the top one and negative 12y on the bottom one. So that'll be opposites, and those can cancel. We'll add the two equations at that point. So we'll actually do that step here. We're going to multiply the whole thing. Now when I multiply the whole thing, I want to make sure that I distribute. So I'll have 3 times 3x plus 4y equals 1. Oops. Put the parentheses in the wrong place. Alright, now I do 3 times 3, 3 times 4, 3 times 1. So I get 9x plus 12y equals 3. Now I'm also going to do 4 times 5x minus 3y equals 21. You do 4 times 5, 4 times negative 3, 4 times 21. And I get 20x minus 12y equals 84. Now, that's wonderful. We can do that now, and let's see what the second step asks us to do. Second step says add the equations in step 1, and then we'll solve the resulting equation for x. So when it says add the equations for step 1, we're going to take those two equations, do 9x plus 12y equals 3. Take 20x minus 12y equals 84. I am going to add those two equations together. So I get 9 plus 20x. 9 plus 20x is 29x. The positive 12y and the negative 12y cancel. And then the 3 plus 84, again that's 3 plus 84, give us 87. Then we divide by 29, and we get x equals 3. So there's our first piece of our solution, x equals 3. Okay, so let's look at step 3. Now that we have 3, we can substitute 3 for x in either of the original equations to find y. So we need an original equation. So we've got 3x plus 4y equals 1. We will do that. 3x plus 4y equals 1. 3x plus 4y equals 1. That is 3 times x is 3 plus 4y equals 1. Do the math. 3 times 3 is 9 plus 4y equals 1. Isolate the y, so we subtract the 9. Cancels. Gives me 4y equals negative 8. Now divide by 4. And I get y equals negative 2. So there's the second piece. So I have this ordered solution, 3, negative 2, that I think works. So I'm going to check the original equation. Make sure it satisfies both of the original equations. So to make sure it satisfies, we just plug the 3 and the negative 2 in for x and y respectively. So 3 times 3 is 9, plus 4 times negative 2 is negative 8, equals 1. That checks out. Now, what's the other equation? The other equation is 5x minus 3y equals 21. Right, so we have 5 times x, and x is 3, minus 3 times y, and y is negative 2, equals 21. And I get 15 plus 6 equals 21, and that checks out. Okay, so the second thing we were supposed to do is use the substitution method for b. Here's b. So our first step is express y in terms of x, and we're going to do that for the first equation. And we do that because the coefficient of y is 1. We could easily solve for x in the second equation and solve it that way, but we're going to choose to solve the first one for y. That means I'm going to take 2x plus y equals 0. I'm going to subtract 2x, which gives me y equals negative 2x. Good. Now I've solved for y in the first equation. Now, the second piece, substitute negative 2x for y in the second equation. Substitute negative 2x for y in the second equation. So, second equation, x minus 3y. So, x minus 3y equals negative 7. But I don't have y. I'm going to put in negative 2x. Now I can just simplify this. Again, this is just solving one equation. Negative 3 times negative 2 gives me positive 6x equals negative 7. And then to solve that, x plus 6x, remember this is 1x. 1x plus 6x is 7x, which equals negative 7. And then I divide by 7, and I get x equals negative 1. Good, I found x. There's one piece of my equation. So I'm going to take that negative 1, okay, and follow the second or the third step here. We're going to substitute negative 1 for x in either of the original equations to find y. So it does not matter which one. I'm going to pick the second equation, x minus 3y equals negative 7. X minus 3y equals negative 7. Instead of x, I have negative 1 minus 3y equals negative 7. And then I need to add the 1, and I get negative 3y equals negative 6. And then I divide by negative 3, and I get y equals 2. Now I have negative 1, 2, and then we're going to check, because that's always what we need to do. We think we have a solution, -1, 2. We check it in both of the original equations. So, step 4 is up here. We'll just come up here, and I will do that up here. So 2 times -1 plus 2 equals 0. That works. -1 minus 3 times 2 equals -7. That works also. So we're good to go. This is indeed our solution. Now there's a caution here. The equations of a system are consistent if they have exactly one solution. Okay, now that's not always going to hold true. So in example 1 for A and B, we had one solution. That meant the graphs intersected. This is saying not all systems have one solution. So we're going to look at example 2, which has part A and part B. Okay, we're going to look at A here. We're going to try to solve these. And first thing we're going to do is put them in standard form. Now some of y'all probably don't remember standard form. So let's refresh ourselves. AX plus BY equals C. That basically means get X and B and Y on the same side, and so we'll do that. So I'm going to take the first equation, 2x plus y minus 1 minus 2y, and I'm going to get the x and the y on the same side. Okay, again, that's the first equation. To do this, I will add the 2y over, and I will get 2x plus 3y equals -1. I will also take the second equation. I'll do the same type thing. 2x minus 9y equals 3 plus 8x. I will subtract 8x, and I will get -6x minus 9y equals 3. Now, I have a system of equations. My system of equations are -6x minus 9y equals 3, 2x plus 3y equals -1. Let's make that -1. Now, these look a lot alike. What I'm going to do is I'm trying to eliminate one variable or the other. So I can either choose to eliminate x, eliminate y. I did y last time, so let's do x this time. So if I notice, that's I got a -6 and a +2. If I multiply this by 3, and I get a new equation, I get 6x plus 9y equals -3. Okay, and I take my original equation here, -6x minus 9y is equal to 3. If you'll notice, those are opposites everywhere. +6x, -6x, +9y, -9y, -3, +3. I end up with 0 equals 0. When this happens, it's an identity. It means it's always true. Basically, it says all solutions of one equation are solutions of the other. In other words, no matter what I get for the first equation, it's going to make the second equation true. The equations are considered consistent and dependent, and their graphs coincide. In other words, their graphs are the exact same line. When you graph these, you get the same line. They are the same equation. Okay, so that's dependent, that's consistent. That's the same thing as having infinite solutions. The last example I'm going to work, it wants us to solve the first equation for x and use the substitution method. So if I take that first equation, what I can do is I can take 2y equals x plus 3. I will solve that by subtracting 3. Okay, and I get 2y minus 3 equals x. I'm going to take this equation I just got here, going to plug it in for x on the second equation. So to write that out, I take 2y, I don't want to put parentheses yet, 2y minus x put a parentheses there, minus 6 equals 0. Well, x is here. That's what would go there. That means we're going to plug that stuff in there. 2y minus 3. I take this down here, so I'll have a little more space. 2y minus 2y plus 3 minus 6 equals 0. Note, positive 2y, negative 2y cancel. The 3 minus 6 is negative 3 equals 0. This is a false statement. Okay, negative 3 equals 0 is false. That means the system has no solution. The equations are called inconsistent and they have parallel lines. Okay, so no solution would be what you would write here, and that would solve our system. The rest of these we'll look at class and we'll try to work through. Remember, we'll have a short quiz over this stuff at the end of class.